Hello dear students, welcome to YourPedia. Today I am going to start with a question that was asked previously in DRDO. This question was asked previously in DRDO interview. Generally, the interview of the companies like DRDO, ISRO, BARC, these are scientific research companies. In these companies, they will start a question which is very simple in the starting. But from there, they will extend that question in multiple directions. They will link that question with other subjects and with other concepts. From one question, they will extend in multiple directions. They will check your approach towards solving a problem and depth of your concepts. They will check your thought process, how you are thinking to solve that question. Okay, so these are very important parameters while answering the interview questions of DRDO, ISRO and BARC. So let's start with the question that what we taken. So this question was previously asked in DRDO. The question is very simple, that is, what is time constant? We all know answer for this one. Let's write what is time constant. We all know that it is the time taken by the step response to reach 63.2% of its final value. Yes, this is the definition. We all know this definition. Then immediately this question was asked, why we are taking step response? Why not other responses like ramp response, parabolic response? Why only step response? Why? Because see, this is the extension of that question. Okay, why? See, if you give this answer, then they'll start asking like this: why step response is taken? Why not ramp response and parabolic response? Why? Because step response final magnitude is a bounded one, means which we can measure. It's a measurable one. If you take ramp response, what is the final value of ramp response? It is infinite. What is the final value of parabolic response? It is infinite. What is the final value of impulse response? It is 0. That's why, see, as the final response or final value or steady state value of step response is a finite value or a bounded value, that's why we are taking step input or step response for finding time constant. Yeah, this is the question. The second question is, let me write here the extension from there, that is why step response is taken. Why step response is taken in defining yes, time constant. In defining time constant. Why step response is taken? I'll tell you. Yes. Yeah. See, the final value, the steady state value, see, the final value is also called as steady state value. The steady state value of step response is a finite value, is a finite or measurable or bounded value. If you answer this way, the immediate next question will be, what do you mean by a bounded signal? Yes, what do you mean by a bounded signal? What is a bounded signal? What is a bounded signal? Yeah, this is the answer. If it is possible to measure the value of the signal at any point of time, then that signal is called as a bounded signal. Suppose if you take impulse, its value is not measurable at t is equal to 0. If you take ideal impulse, its magnitude is infinite at t is equal to 0. It is unbounded. Okay, if you take ramp input at t equal to infinity, the ramp signal value is infinite, it is not measurable. If you take parabolic signal, yes, its value is not measurable at t is equal to infinity. But if you take step input or step signal, its value is always constant. At any point you can measure its value. That's why step signal is called as a bounded signal. Yes. Now what is the answer for this? If it is possible, if it is possible to measure the magnitude of the signal at any instant of time, then that signal is called as bounded signal. Yeah, if you come back, yes, what is the definition of time constant we taken? Yes, sir, it is a time taken by the step response to reach 63.2% of its final value. Then a question can be framed. Yes, yeah, a question got framed in fact from this one, that is why you are taking 63.2%? Why you are taking 63.2%? Why not some other percentage? I'll tell you. Yes, why 63.2 is taken as why? Yes, why 63.2% is taken when defining time constant. Why it is so? Yes, I will tell you. Observe, there is no great reason behind it. If you take the value, actual time value equal to one time constant, then the response is going to be 63.2% of its actual final value. Suppose, for example, if you take a series RC network, yeah, this way we have to proceed. For a series RC network, voltage across capacitor, yes, voltage across capacitor is, in bracket I'll take it as Vc of t, or voltage across capacitor Vc of t is equal to V into 1 minus e power minus t by RC. Yes, what is the time constant of, or let's complete this one, then we'll go for the next question. Now that Vc of t can be written as V into 1 minus e power minus t by tau, where tau is time constant of series RC network, time constant of series RC network, time constant of series RC network. Now what is our variable? This is the actual time. Yes, that is the actual time that starts from 0. If I take that time equal to the value of this time constant, this one time constant, then yes, Vc of tau means when t is equal to tau, how much I am getting? V into 1 minus e power minus 1, that will be 0.632 times of V. This V is the final value. Yes, this V is the final value. Observe here carefully. This V is the final value. What do you mean by final? Steady state. As t tends to infinite. Yeah, what is the final time in our circuits? Where as t tends to infinite. If you put t is equal to infinite, e power minus infinity is 0, 1 minus 0 is 1, 1 into V is V. So see, 0.632 times of V means 63.2% of its final value. Okay, now the question arises here. Yeah, we given answer that for a series RC network the time constant is RC. Now then they will extend that question. They will extend that question like this: what is the time constant of parallel RC network? Parallel RC network. So we given the time constant of a series RC network as RC, then what is the time constant of a parallel RC network? That is also RC. See, tau for a parallel RC network, for a parallel RC network is equal to RC. Then immediately the next question will be, what are the units of time constant? Yes, what are the units of time constant? Yes, we will answer that. Yes, sir. The units of time constant are seconds. Yes, units of time constant are seconds. Units of time constant are seconds. Then immediate next question will be, can you prove that R into C will give seconds? Yeah, we are saying that units of time constant are seconds. Can you prove that R into C as seconds? Yes, we can prove. Yes, we can prove. Let's do that. Let's do that. Observe here, all of you carefully. R into C units I need. R is in ohms. C is in farads. Let's keep ohms as ohms. I know one formula that VC is equal to voltage across capacitor is equal to, yes, or not VC, let's take IC. That is easy for us. Let's take IC. Let's take IC. What is IC? Current through a capacitor. Yes, current through a capacitor, IC is equal to C into dVC by dt. These units are amperes, capacitance units are farads, dV means voltage, difference in voltage, that is volts, dt units are seconds. Now farads can be written as ampere second by volt. Let's replace this farad with ampere second per volt. So this R units are ohms, ohms into ampere by volt into seconds. Volt by ampere is ohm, then ampere by volt is mhos. So this and this will get cancelled. We are left with finally seconds. We proved it. The units of time constant are seconds. R into C is giving seconds. Then again there will be a cross question. See, can you prove that without solving the time constant of a parallel RC network as RC? Yes, we can prove. See how this is the question. This is the question asked. This is the question asked. All these are the questions previously asked in DRDO interview. From that first question, that is what is time constant. From there these questions got extended. From there these questions got extended. How can you prove that? How can you? Yes. How can you prove that the time constant of parallel RC network is RC without solving the circuit? So it means you should not take the circuit and find its current expression or voltage expression. You should not do that. Without doing that, yes, orally we can prove. That is very simply, whatever may be the formula of time constant, its units must be seconds. Yeah, this is the circuit. I am taking a current source here. This is DC current source I am taking. I am taking some resistance here and some capacitance. This is parallel RC network. This is R, this is C. Okay, so this circuit is having, so this current will take it as IR of T, and this current will take it as IC of T, and voltage across this capacitor will take it as VC of T. Okay, now this circuit time constant I want, we already know that its time constant is RC. Its time constant is RC. If you want, you can derive. But what is asking without deriving, how can you prove that, or how can you support your statement that the units of time constant are the units of time constant are seconds? We know that this time constant formula is RC for this one. See, we know that the time constant of a series RC network is RC, but for parallel RC network is also RC. Why, you know? See, simply, very simply, the units of time constant are, yes, units of time constant are seconds. Whatever may be the circuit may be series RC, parallel RC, series parallel, whatever it is, the time units are seconds. Now, previously, if we take RC, see, these are the possibilities. These are the possibilities of time constant. See, these are the possibilities of time constant. See, RC is one possibility, R by C is another possibility, C by R is another possibility, R square C is another possibility, RC square is another possibility, R square C square is another possibility. Like that, many possibilities are there. But among these possibilities, why I am taking those possibilities? My circuit is having only R and C. The combination of those two elements only I have to take. Now, from that units and dimensions, we got these units are seconds. If these units are seconds, does these units are seconds? No. 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 So the only possibility to give the seconds as units is R into C only. That way, very easily we can say that either it is series RC or parallel RC, the time constant formula is RC only. Some people, they will think like this: if series RC, the time constant is RC, for parallel RC, it may be 1 by RC. Yeah, this is one more combination. I forgot to write that. Yes, this is one more combination, that is 1 by RC. No, see, very simple. If RC is giving a units of seconds, now what are the units of this one? These units are 1 by seconds, nothing but frequency. But time constant means it must have the units of seconds. So this way directly we can prove. Okay, now yes, this is the question asked after that question, extension of that question. So they asked, I want a circuit, draw a circuit, RC circuit, in such a way that its charging time constant and discharging time constant are different. Please listen to the question carefully. Draw a RC circuit, draw, yes, this is the question. Draw an RC network with a different charging and discharging time constants. What is the time constant of RC network? RC. Time constant, either it is series RC or parallel RC, the time constant of RC network is RC. Now, observe here. What do you want? He want that capacitor to have one charging time constant and other discharging time constant. Yes, this will solve our purpose. Observe. I am taking a voltage source. I am putting a switch here. Yes, I am putting a switch here. Observe here carefully. Yes, this is the resistance. This is the capacitance I am taking. Let me take this one as R1 and this one as C. Now, from basics of our networks, we all know that this voltage source is charging this capacitance. Okay. Now tell me, what is the time constant of this particular circuit? Tau 1 is R1C, or charging time constant is R1C. Now what I do is, I'll put one more switch here. I'll put a resistance here. Yes. Yes. See, this is closed. Okay, this is closed. So these two switches are not closed at a time. Okay. When this is in closed position, this is an open position. When this is open, this will close. This is called as make before break. I am breaking this one, but before doing that, I am going to make it. Okay. Now I'll take this one as R2. I'll take this one as R2, resistance R2. Now the charging time constant. Yes. The charging time constant. This capacitor is charging via this path. This is the charging path. Okay, this is plus minus Vc of t, and it is discharging in this way. In this direction, it is discharging. This is discharging in this direction. Yes, Charging is this direction, discharging in this direction. Now tau charging, yes, tau charging is equal to, yes, tau charging time constant, charging time constant is equal to R1C seconds. Yeah, it is charging this way, it is charging this way. Yes, this is the charging path. What is the discharging path? Tau discharging is equal to R2C units are seconds. R2C units are seconds. Units are seconds. R2C it is. Now he will ask the next extension of this question. I want discharging time constant to be more when compared to charging time constant. You can relate this one with your cell phone. Your cell phone is taking less time for complete charging, but it is taking a lot of time for full discharge. Yes, so we have to design our cell phone battery and its circuit in this way. Our cell phone battery must charge very fastly and it must discharge very slowly. Yes, so that example you can relate here. I have two different time constants. One is charging, another one is discharging. Take this capacitor as your phone battery. Okay, now it has to charge very fastly, but it must discharge very slowly. That type of cell phones only will prefer. If it is taking more time for charging and less time for discharging, so charge will complete within less time. Then always we have to keep our charger plugged in, right? So now see the next extension question is yes, if it is needed to have more discharging time constant, than charging time constant, what will be the relation? What will be the relation between the parameters? What will be the relationship between the circuit parameters? Yes, observe here, what is charging time constant? Tau 1 is equal to R1C, tau 2 must be equal to R2C. We want tau 2 to be greater than tau 1, therefore what it is? R2C must be greater than R1C, means R2 must be greater than R1. We have to select this way. R2 must be greater than R1. That way we have to select our resistance values, not just some random resistances. Now one more question extended from this question. Let me draw that figure and I'll explain you what they asked. Okay, so here this is a circuit, yeah, previous circuit only, this is a circuit. Yes, so this circuit you will draw in the interview. From that one only they will be asking many questions. Yes, observe here carefully, ma. Yes, observe here. Yeah, this is a resistance, capacitance. Yes, there is a switch, there is some resistance. This is let's take they'll give it as some 10 ohms, this one as some 1 microfarad, and this one as some 1000 ohms or 1 kilo ohm. 1000 ohms, let's take 1000 ohms. This is V, this is R1, R2. Yeah, R2 must be greater than R1. If it is required to reduce the discharging time constant further, if it is required to decrease the discharging time constant further what you will do, what you will be doing. Yes, think. I want the discharging time constant to reduce further. Can I decrease this 10 cube? It is already fixed in the circuit. We should not touch that one. That element is already fixed. Don't say that, to increase. Yeah. So, yeah, the question is, if it is required to decrease the discharging time constant further, what will you do? Means you want to decrease the discharging time constant. Discharging time constant is more when compared to charging time constant, but you want to decrease it further. Then what will you do? Without touching this 10 cube, without touching this 1k ohm. What will you do? Yes, that is very simple. Yes, if you have the fundamentals of electrical circuits, connect one resistance in parallel with 10 cube. Yes, parallel will decrease the resistance. See, if I am taking two resistances R1 in parallel with R2, this value will be less than that of the least value of resistance. Suppose if I am taking 10 ohms in parallel with 1 ohms, this will be less than 1 ohm. So what is a simple procedure here? Now we have the circuit, that is this one, voltage source. Yes, this is the resistance R1. We have nothing to do with the R1 now. Now we want to decrease the discharging time constant. Yes. This is a 10 cube ohm. This is a 10 ohms. This is a 1 microfarad. This is some voltage V. Value is not mentioned, not required to mention even. Now connect a resistance here, R3, whose value is less than 1000 ohms. Then see, we are not disturbing this 10 cube. That 10 cube is as it is. We are introducing one more new resistance in parallel. Okay, now we know that 10 cube in parallel with R3, which is less than 10 cube ohms, will give less than 10 cube ohms. Means this entire effective resistance got decreased. Then obviously tau 2 is equal to, I'll call this one as completely some R3 into C. We know that R3 is less than 10 cube ohms. Just now I explain you that. See, you must have this point. If two resistances are in parallel, then the resultant resistance will be less than that of the least resistance. Means if you take 10 and 1 in parallel, the resultant value will be less than that of 1 ohm. So this way, one question after another in interviews like DRDO, ISRO and BARC, they will extend and they will link with multiple subjects. Thank you.